This video is made with the purpose to help increase education on smart grid technology, a technology with the potential to increase the efficiencies of the electrical system and reduce the greenhouse gas emissions associated with it. The need for electricity is growing with no sign of slowing down. In 2017, Canada alone generated 650 terawatt-hours of electricity, all based on an electrical system that has not changed since the 1950s. The current system forces daily estimates of power requirements, which often results in many generator facilities waiting on standby, which may increase the cost of electricity, even if they are never used. Not only does the system not allow for effective information exchange, it also makes integration of residential or external renewable generators, like solar panels and wind turbines, very difficult. Without two-way communication, much renewable power is delivered at inopportune times. While the current system works, the Government of Canada agrees that the efficiency can be greatly improved while also reducing carbon emissions. One approach they are considering is the use of smart grids. Smart grids are not a single physical thing, but rather a method of demand-side electricity management using several components: smart meters, telecom wiring and wireless communication, and control centers. Smart meters are electrical monitoring devices installed in homes, buildings, or whoever needs the electricity. Telecom wiring and wireless data transfer allows this data to be communicated between the customer and the utility. Microgrid control centers are the main control points for the system and are where the local grids can be controlled. These can range in control size from a single house to an entire community.
There are many benefits in using smart grids, including benefits to customers, the operators, and the overall grid. With smart grid technology, you can manage the peak loads, transmission, and distribution. Not only does this make the overall system more effective, it has potential to reduce costs significantly, as about 40% of grid infrastructure costs are for generation capacity, and another 40% are for distribution systems. Smart grids will reduce these costs by maintaining adequate reserves for forced contingencies and outages, and by managing demand at the substation level. This leads into the additional benefit of reliability and resiliency. With smart grid interconnections and controls, if there is a fault within the system, that fault can be isolated quickly and distribution can be rerouted. In terms of energy savings, a review of studies in 2006 included that energy consumption can be reduced by 5 to 15% with various feedback forms. The higher end of this consumption reduction is provided by using real-time feedback. For customers, they can see many benefits through bill savings and incentives to modify habits in response to the current supply. That is, they can decide to do laundry or other energy-consuming tasks during low-demand times to increase bill savings. Additionally, customers can benefit from selling energy from their electric vehicles back to the grid during peak times to reduce the overall load on the system.
Social acceptance is a key factor for widespread integration of new technologies and often the most difficult to achieve. Smart grid technology is no different, and few complaints against it have to do with the viability of the technology itself. The most outspoken opponents are individuals who object to smart meters being installed at their home. Many arguments against smart meters stem from uncertainty on the security, reliability, and privacy of the technology and a general distrust of the utilities. Customers have complained about mysterious overcharging on their bills and the mandatory costs of installation. Others assert their right to privacy inside their own homes and are concerned about utilities selling their use data. On a broader scale, there are concerns that some industries will be more affected than others. Hospitals, for example, must run all day, every day, and are high energy consumers due to the equipment, sanitation, and climate controls that must be available at all times. Hospitals will therefore not be able to adapt their habits to save, and the increased costs will be borne by the people through taxes or higher prices for care. Others have stressed that while smart grid technology may be sound, there is not yet enough security in the system, and if the grid is online, millions will be vulnerable to terrorism by loss of power control if the grid is hacked. With increasing energy demand and concerns about cost to users and to the planet, smart grid technology is a powerful tool to upgrade the reliability, resiliency, and lower the price to consumers. The technology is available and sound, but concerns from the public highlight the need for education to increase literacy on smart grids and to address concerns about privacy and cost. It is also paramount that there be cooperation between utilities and policymakers to ensure the safety and security of all citizens.